Welcome to Straight Science, everyone. Straight Science is an evening seminar series put on by University of Alaska Fairbanks Northwest Campus and also University of Alaska Fairbanks Alaska Sea Grant. Both Northwest Campus and Alaska Sea Grant. We are public servants of the Bering Strait region. We serve all peoples of the Bering Strait region, which is the homeland and waters of the Inupiaq, St. Lawrence Island Yupik, and Central Yupik peoples. Now, tonight we've got a topic. I was saying earlier, I was raised with the threat of acid rain, and ocean acidification has just been some words to me that kind of remind me of that, and I'm not a chemist. So I know it's important, and I know it's a threat to Alaskan waters, and it's important that we all learn more about it because it's something that now is we have to look out for. Add it to the list. And so we've got no one better to tell us that tale, give us an education, and let us know what's going on up here than Natalie Monacci. Natalie is calling in tonight from Fairbanks, and she is the director of the Ocean Acidification Research Center at the University of Alaska Fairbanks College of Fisheries and Ocean Science. So she's in the inner sanctum and will be able to give us a good perspective and education and hopefully good news on ocean acidification. So we're so glad you're here, Natalie. Take it away.
Thank you so much, Gay. I really appreciate the introduction. I'm here living and working on Tanana Dene land at the Trothuda campus at University of Alaska Fairbanks. I really appreciate the opportunity to call in and speak with you tonight. I'm going to give a pretty long introduction to ocean acidification, and then I'm going to get into some of the results that we have from some monitoring projects in the Bering Sea, and then specifically in your Bering Strait region. So I'm going to turn my camera off here, so hopefully the slides kind of advance a little bit better, and then it might be hard for me to see if anything goes awry. So if you can't see or you can't hear, please just come off mute and just let me know.
We'll let you
Um,
know, and we'll also monitor the chat box for you.
oh, super. Thank you so much. So I think the first thing I usually like to do when I give these talks is start out with my, end message. So a lot of the times it's kind of like, where are we going? Where are we going? And then you finally get the message at the end and it kind of connects everything. I'm going to give you our final take-home message right up front. So there's three main things I want to point out tonight. The first is that ocean acidification is a part of climate change. It's not happening alone. It's not a totally different thing. It's all the same thing. It's happening in tandem with other climate-driven stressors, such as warming, decreasing sea ice, harmful algal blooms. All of these things are happening at the same time. The next point I want to make is that Alaska in general, our giant, huge Alaska with all of our coasts, is a hot spot for ocean acidification. This is primarily due to natural factors, and I'm going to explain this more. But the waters in North Pacific are old and cold and naturally near biological limits. And the final point I hope to make to you is that the response to ocean acidification is species specific. So when I get into some of the results, I want you to kind of pull back a little bit and think about there's a lot of different things that live in the ocean and they all respond differently to whatever conditions we might be monitoring and giving you results about. So I'm going to try to cut down on some of the acronyms. I know I can never keep up with the alphabet soup. One that might slip through is OA. That's ocean acidification. I'll try not to say that, but just to kind of give you a heads up on that. And now I'm going to give you a few more details about these points. And these details are really coming from everyone you see here in the photograph, and then a lot more people. So this is the Alaska Ocean Acidification Network, and they really contribute to most of the message that I'm gonna give you here today. So again, ocean acidification is a part of climate change. This is a quick reminder about carbon dioxide accumulating in the atmosphere. So this is a result of human-related emissions that's shown by the red line here. And these values you've probably seen before. This is monitored at the famous Mauna Loa station in Hawaii. But what you might not have seen with these air values is what's happening with seawater CO2. So the seawater is shown in the green line, and it is increasing right alongside the values that we see in the air. So 25% of the carbon dioxide that humans release to the air is absorbed by the ocean. So this is why that green line is also going up. So after the carbon dioxide enters the ocean, a series of chemical reactions take place, and this lowers seawater pH. So the blue line here is showing pH, and it trends in the opposite direction. So the higher the carbon dioxide in water, the lower the pH. And I said earlier that Alaska is a hotspot for ocean acidification. So these global maps on the left show one of the metrics that I measure, and I'm going to define this later. It's called saturation states. But for right now, the point here that I want to make is the more unfavorable conditions for our marine species is shown by the yellow and the orange colors. And those are really focused here on the poles. So this emphasizes the point that in pre-industrial waters, the waters around Alaska were naturally preconditioned to be low. The bottom map is looking into the future. This is surface ocean predictions for 2100. We're seeing these yellow and red values expand and move southwards and intensify. And these are the most unfavorable conditions to marine species. And this work is really based off of an international effort to monitor carbon in the oceans. So the summary of this is released every year at the Conference of the Parties. This is what just that big thing in Brazil that just happened that some of you might have seen in the news. And they released the 2025 global carbon budget. And that's where all the international decision makers are making their decisions based on. So I observe seawater carbon dioxide, so I contribute to this effort every year. And the point I really want to make here is over on the far right, this large kind of green teal value is that dissolved inorganic carbon in the ocean. It is the largest carbon reservoir that we measure. It performs a huge service for the rest of the planet to dampen the effects of climate change. The ocean absorbs 90% of the heat that is attributed to climate change, and it's also absorbing 25% of that excess carbon dioxide in our air. This is what's changing our marine ecosystem chemistry. And then the chemistry is important to me because I'm a chemist. I'm a chemical oceanographer. That's my training. But what matters to everyone else is really the species. So it's what we eat, it's what we make our livings off of. And so I'm going to give a few examples on the response to ocean acidification. So a lot of the early articles were usually showing pictures of dissolving shells. That was often a type of plankton called pteropods, which are a major food source for a lot of different marine species. So the chemical process of ocean acidification reduces the carbonate in seawater. This is the same carbonate that species are building and maintaining their calcium carbonate shells with, like pteropods and clams and oysters. But many organisms are sensitive to changing ocean chemistry that do not have calcium carbonate shells. So we're talking about the effects on all marine species here, not just shelled organisms. So a lot of the research is on finfish. So they can be affected through behavior, growth, reproduction, and survival. So they study all of those metrics to determine the response based on which species they're interested in. So again, I'm a chemist. The biology to me is really hard, right? Like nothing reacts the same way. Nothing's predictable to me. Some are resilient, some are affected. And then you look at a different life stage or a different generation, it's all completely different. So I'm really grateful for the Alaska Ocean Acidification Network and all their great resources. They summarize all of the information of the response studies from the biologists. So a quick list is What we know is mostly from lab studies. So that means the species has to be able to survive in a lab for those biologists to be able to study them, first of all. That's not many species. We have 23 Alaskan species that have been studied so far, including 6 seaweeds. And the screenshot of the website in the middle, you can go and click on each one of those, and then they'll list the different species under that category and give you information. There's a lot of different ways to vary the treatment when they do these physiological response studies, and that can also include looking at those co-stressors. So ocean acidification is not happening alone, and it's usually sublethal. So it might not be what's going to kill the organism, even if they show negative effects. It's often those co-stressors, those changes in temperature, or some of those other metrics that is often lethal to the species that they're studying. And then the lab data can help us better interpret the data that I observe out in the field, and then vice versa, where I might go to the fisheries biologist doing the response studies in the lab and say, these are the values we're seeing now. How does this match up with your work? So just a few highlights here. We'll start with finfish. So a lot of this work is done by the Alaska Fisheries Science Center. They have several labs, but the one that does the groundfish studies is led by Tom Hurst and Emily Schlesinger in Newport, Oregon. And they tell me that they found no effect of high carbon dioxide on egg survival and hatch size for northern rock sole, but they did see a reduced growth and higher mortality at the larval stage. Arctic cod showed no effect on larval mortality and length, but their condition was reduced, and then they had higher energy demands as a result of that. The Pacific cod showed no effect on larval mortality or growth, but they did have reduced egg mortality, and their behavior and their physiology was altered. And so far, the research on pollock have not shown as many negative of effects as some of these other species, and they appear to be more resilient to changes in ocean chemistry. So whenever I give these talks around the state, I always have the most questions about salmon, and it's a real bummer for me and everyone I'm talking to because we have the least information about the effects on ocean acidification on salmon. So there is some new research led by the Kelly Lab here at UAF. Their early results say that coho and pink salmon show some sensitivity. Juvenile pinks had slower growth, smaller body length, increased metabolism, and higher stress. Adult coho showed an impact to their sense of smell. So we have a new working group within the Alaska Ocean Acidification Network that includes fisheries biologists that are trying to learn more about the effects on salmon. So if you subscribe to the network, we can give you updates on the news, but there's just not a lot to report right now. So the next species I want to highlight is crab. So much of the research that's been done is led by the Alaska Fisheries Science Center in Kodiak. The take home here is that we do not say ocean acidification affects crab. The species here is very important. So for blue king crab and snow crab, the lab results are showing resilience to ocean acidification. Research shows that temperature had the largest effect on the recent crash of the snow crab fishery in the Bering Sea. And lab results show resilience to ocean acidification whenever they study them at elevated levels of carbon dioxide and low pH. This is not true for red king crab. That's a completely different story. And a big change in our messaging came just this year. So for the first time, we have evidence that shows a possible connection between ocean acidification and recruitment failure of the red king crab fishery in the Bering Sea. So there's still a lot of work to be done here. It's not a total smoking gun, but we're going to continue to update all the latest information at the network. So please stay tuned for more of those details as they come out. Okay, so that wraps up the biology section, and now we're going to move into the monitoring section. That's a relief for me because that's what I do every day. Earlier, I said that the biological laboratory experiments on different species can vary their treatments in a lot of different ways. Some match their conditions to what we're monitoring. So these pictures are just a few ways that different members of the network monitor around Alaska. There's two main approaches. One is taking seawater samples collected from a research ship or your dock or your beach or anywhere else, maybe your mariculture farm or a fishery survey, and then we bring that sample back to a lab to analyze. The other approach is to record data on a sensor that's either moored at a fixed location. It might be plumbed into the seawater system on a ship or a ferry, or you can put it on a drone that can move around remotely. So now I'm going to highlight a few of the monitoring projects that I've been involved with in the Bering Sea. So this map shows many of the places around Alaska we've collected data. It doesn't show the drone tracks, but I'm going to show those in a couple of slides. But the point here really is to just let you know what our monitoring goals are. So the first is to learn something about temporal duration. That's how long we see an ocean acidification event. We want to know the spatial extent. So where is that? This map here is just latitude and longitude, but we're thinking in 3D here. So we're also thinking about where that is in the water column throughout the, from top to bottom. And then also the biogeochemical intensity. So that's the value of whatever monitoring variable we're using. So here's a list of those variables that we often discuss, and you might see in some of the reporting that you're given if any of your communities are monitoring for ocean acidification. So remember, this is a component of climate change. So any changes in carbonate chemistry are not happening alone. It's alongside rising temperature, changes in sea ice, and everything else. So we have that handy graph in the lower left-hand corner to kind of remind us that as seawater CO2 increases, seawater pH decreases. And then I'm going to define saturation state in great detail. And then I'll also just define the different thresholds or levels of intensity for each one of these variables. So if you ever see reports or maps or information about this later on, you should have like a frame of reference to how to think about those numbers for each different variable. I'm going to start with carbon dioxide, and I usually think of that data in terms of, is it less than or more than whatever the air value is. Today, that air value is around 426. And then the pH and the saturation state values are set by the biologists who do the species response studies. So here I'm showing you surface seawater carbon dioxide from all of our buoy sites in Alaska. So we have this inset, this map of Alaska here. The blue dot and the blue line match. That's the M2 station in the southeastern Bering Sea. The green dot and the green line is from just out of Seward. The gray dot and line is off Kodiak in Chiniak Bay, and the black line and dot here is from the buoy that we used to have in Southeast Alaska in Chatham Strait. And then the red line is approximately air. So I want to emphasize two main takeaways from this graph. First, there's a lot of wiggles. This is just driven by regular daily and weekly variability. But overall, the trend shows a decrease in surface seawater CO2 in the summer. So on the x-axis here, we have the months, and then the y-axis is the carbon dioxide value or intensity, and we have the lower values in these summer months. So this decrease begins with the spring bloom. So phytoplankton in the ocean are plants. They're taking carbon dioxide out of the water for their photosynthesis. This is drawing that seawater signal down. The second point I want to make is that the seawater CO2 values at the surface that are the highest in our record is in Southeast. So if I go back to what is our monitoring objective here, what is the duration, extent, and intensity of ocean acidification, my answer would be CO2 is highest in the winter and in Southeast. Okay, so that's just an overall general picture of how we begin to think about carbon dioxide around Alaska. But we really care about the Bering Sea here in this group, right? So here's all the data that we have from the M2 long-term mooring site. The surface buoy is affectionately known as Peggy after Peggy Dyson, which some of you may know or used to listen to her on the radio with her reports. And this is only out seasonally during the sea ice free season, supposedly. Okay, so the blue dots is this year's raw data. So this isn't processed, it's just what I got back this year. That's from the every 3 hour sampling interval. And then I highlighted the 2023 data here in black, in this black darker line, and then the darker gray line is the 2021 data. All the other data is the years of deployment since 2011. All the lines are 5-day smoothed averages. So we had some major recovery issues in 2021 and 23. This was super bad for our logistics and our bank accounts, but it gave us a really rare glimpse of the conditions during freeze up. So it was really awesome to catch these signals. So most of our data show those negative values during a lot of the growing season. So that's when the phytoplankton are using the carbon dioxide out of the seawater. And in the winter data, we see mostly positive values here. So the positive versus negative here is really just the way that I'm looking at the difference between the values that we're collecting in the air on the kind of the top of the buoy, and then just below the water line on the bottom of this buoy. So the difference between those two. And the winter data is mostly positive. So that seawater value is higher than air because everything in nature likes to be in equilibrium during this time. You know, the air and the surface of the seawater is constantly exchanging things. And on average, the ocean is a sink. So it's absorbing that CO2. But occasionally it's a source of carbon dioxide to the air. We've always known that the Bering Sea periodically outgasses or burps out this excess CO2 in the winter, but the direct observations are rare. Most ships with our sensors are not in the region. And storms and intense winds, you know, as you all know, are mixing the water column in this region top to bottom. And so it's bringing up the CO2 from deeper in the water column, and it's allowed to escape or outgas to the air. So I think it was just a week or two ago, Rick Toman gave you all the Straits Science webinar on ex-Typhoon Halong, and we did not have our gear in the water when that came through. These blue dots end at the end of August, and the same with Murbach in 2022. So that's just to give you a kind of reference that these other mixing storm events were still strong enough to really, really outgas a lot of this carbon dioxide. So let's again go back to our goal to monitor the duration, extent, and intensity. This is an anchored buoy. It's in one spot. So it's telling nothing about extent because it's not moving around. It's in the same place at all time, but it's an excellent record to give us information about duration because it's out there for a long time in the same spot, and intensity on what the value is. So how do we monitor extent? One of the tools in our toolbox is a sail drone. This is an uncrewed surface vehicle that you can outfit with CO2 sensors along with a lot of other fun toys. We had our sensors installed from 2016 to 2021. This figure was produced by Hongji Wang, and she has another paper coming out next year, so we'll be able to give you some more information then. And here the values are in terms of CO2 flux, but the story is the same. The negative values, the green and blue values are less than air, and the higher positive values, the orange and yellow values are greater than air. So these missions always took place in the summer. So we're seeing outgassing even in the summer. And that's not something that we record very often because we don't have a lot of things out there doing really fine scale sampling. So this was really excellent for us to be able to catch a lot of fine scale data that we've never had before. So overall, the average from this project, the Bering and the Chukchi Sea are still very strong CO2 sinks overall, but there are areas of outgassing. That includes in the Yukon River plume. So in this 2021 year, this farthest graph on the right, The sail drones spent several weeks doing repeat transects in and out of Norton Sound and around the plume. And so we got some really great information there and some of the outgassing that we saw. Okay, so I've talked about moorings and drones. I'm going back to the map to talk about the ships and some of the other monitoring variables. We have data from all around Alaska, so if you're curious about other regions, we can talk about that. But now I'm going to zoom in on the Distributed Biological Observatory Project. And I think OPIC is on the line, who has sailed on these cruises and has helped collect all this data. So thank her for all of this. And our goals are the same regardless of which project we're doing. And we just want to monitor duration, extent, and intensity. So the earlier phase of this project, the Distributed Biological Observatory, was done aboard the Healy, and the current phase that we're in now is on the Sekuliak. And I'm really grateful for the opportunity to share these results with you because, like when Katrin Eichen gave the Strait seminar right after this year's cruise ended, it's a general report of what happened on the ship when they were out. But a lot of the information that we're collecting, including my project, we don't really have any results until much later. So this is a great opportunity for me to do the report back. So the most interesting thing to me about this project is, the different timing. Like we're totally at the mercy of the ship's schedule. We don't always get to choose when we want to be out there. So sometimes our cruises are in August and then other times they're in November. There's not a lot of ships going out there doing very large surveys, especially for carbonate chemistry in the winter. So this is really great for us to have these data. And I'm going to focus here on these transects 1 and 2 outlined on this total project map for your region. We occasionally visit the stations in the Bering Strait, but not every year. But we do hit DBO 1 and 2 every year. Okay, so we talked about carbon dioxide for a while. Now we're going to move into the pH part of the talk. So earlier, I really enjoyed you, Gay, saying, you learned about acid rain. And acid rain is acidic. So if you look at the total pH scale here from 0 to 14, acid rain is below 7. 7 is neutral, and then anything above 7 is basic. But the average surface ocean pH is 8.1. So the pH of 8.1 is not an acid. So acidification is a relative term. As the oceans absorb more CO2, the pH is decreasing, and it's making things more acidic than pre-industrial times. So on the maps of the work I showed earlier, there's all these blue dots. That's where we have all of our data collected that we send off to public archives so that people are able to make synthesis products. So this map here is an example of a synthesis product. This is the Ocean Acidification Indicator Atlas for coastal North America, made by Li-Ching Zhang. And the take home here is that this map is mostly blue because the average surface ocean pH is 8.1. And on this scale, that's here in the blue range. This range is from 7.4 to 8.3. So the pH scale on all the maps that I'm going to show is only a small portion of the total pH. So 7.4 is still not acidic. And let's see, what else do I want to say? Oh, yes. So this is the surface, but all of the creatures that we care about don't always live at the surface. So what happens deeper in the water column? So here I'm showing an example again on the website. You can go and you can pick any variable you want in any depth. Here I picked depth of 75 meters. And the values are showing these lighter blue and green colors. That's lower pH. pH naturally decreases with depth. So if we look at the average of pH on the right versus on the left, it's lower, which we would expect. And that species response study summary that I highlighted earlier, they give us the metrics on how to think about what these numbers mean to our favorite fish or crab or anything else. Most species are not studied, and we generally pick this pH of 7.8 as kind of a general metric to use. If you have a number that matches your favorite species, you should use that. But again, we don't have numbers for most species. So I'm going to focus on that 7.8. That's this change in between green and yellow here. Okay, so this is the data from your region. So I have the national map here on the upper left as kind of that reference of the average data. And then I'm showing you the pH at multiple transects. That's the DBO1 south of St. Lawrence, DBO2 north of St. Lawrence. And then in this year, we did visit the Bering Strait samples. So we have those data out here. And these colors are all different than this average map because this map is averaging everything. And so if we look at each cruise, it's telling us specifically about what that snapshot and time was. It tells us nothing about duration. It's only what the conditions were at the time that we were there. And then this cruise happens at different times all the year. I'm most interested to look at the differences between August and November. So here I'm showing you the November data. This is from 2021. I don't want to focus too much right now on the different years. I really want to think about just the different seasons here. So overall, at all stations, we did not visit the Bering Strait stations that year, but overall, these colors are lighter blue and some greens, so lower pH values than we have in August. Now we're going to take a look at the bottom water. So in the bottom water, we see values that are approaching or crossing this 7.8 number that we like to think about our numbers and what this means. So this is when we start to see negative responses in the crabs and the finfish. So the take home here from all of the maps that I give a summary when we produce these reports is that we see lower pH in bottom waters and we see lower pH at DBO1. So that's just kind of a top level summary of some of the data and the way that we think about the variables from this cruise. Okay, so next I'm going to introduce the next variable, that's saturation state. And we like to use the omega symbol to define this. So saturation state is how we measure the availability of carbonate ions in seawater for marine species to build their calcium carbonate shells. So the scale we have here on the map ranges from 4.5 in the dark blue to 0 in the red. And it indicates we're talking about the saturation state for the mineral aragonite. This is the more vulnerable calcium carbonate mineral in shells. So there's a different mineral called calcite that you could pick on this atlas. But since aragonite is the more vulnerable mineral, that's the one I'm choosing to just give examples of today. So the response studies tell us that oysters begin to experience stress when this value is less than 2. We use a threshold value of 1 to indicate where carbonate becomes undersaturated in seawater. But like, what does that mean? This to me is an extreme threshold. It's a physical chemical threshold that has a very specific mathematical definition. And everything I know about biology is that it does not follow mathematical definitions. So I tend to think of omega-1 as an extreme threshold. And if you don't have information about your favorite species, that's what you can use. But again, like, what is undersaturation? So it means that it requires a lot more energy for your organism to maintain its shell. So if you put all of your energy to keep your shell nice and strong, then you have less energy to do things like grow big and reproduce. It does not mean instant death. It also does not mean your shell is going to completely dissolve away. So these numbers are red, so they're kind of alarming. And when we say things like crossing thresholds and undersaturation, it kind of puts this very serious message on top of things. But again, I want to remind you that most of the response studies that the biologists do are sublethal. That means it is not killing the organism when they test them at these conditions. So here we have the values are lower around Alaska. Like I said before, we're more vulnerable. This saturation state is really affected by temperature. So we have lower values where the water is colder, and then it decreases with depth, just like pH. So you know what's coming. I'm going to show you the same exact maps from pH, but now we're just looking at saturation states. So when we give all this data to the biologists, they like to see pH when they're thinking about finfish and crab, and they like to see aragonite saturation state with things with carbonate shells, so clams or pteropods or whatever. So the yellow, orange, and red colors are that omega less than 2. So that's where we're told oysters begin to see stress. And we see that in every single map that we have, regardless of water depth or year. So we have these yellow values, less than 2, um, in the Bering Strait stations. So the summary of the saturation states from this project is that we see water conditions that are unfavorable to sensitive marine species in all years and at all depths. There's still a lot of temporal and spatial favorability. Like all of these colors are not the same everywhere. But the take home message is that we have low saturation states in this region, period. Okay, so this is offshore work. This is work that's done sometimes a far distance from where people are collecting their food that they're eating every day and feeding to their families. There is a whole nother large group of people that are doing this monitoring right on shore. This is mostly indigenous led. And some of the dots on the map here are most of the communities. We might have one or two that might have a few data points in the past, but maybe have kind of stopped or it's been intermittent. So if you know of a community that's collecting samples and I don't have it on here, please correct me and we'll get that fixed for you. So the color coordination is usually aligned with who's running your samples. So the Alutiiq Pride Marine Institute is under the Chugach Regional Resources Commission umbrella. So they're running all of the samples collected from communities within their region. So that's Seward, Kasilov, Cordova, all of these in here. But then they're also running samples from any community that doesn't fall under the other two hubs. So that includes you all in Nome and Little Diomede and most of these West Coast Alaska communities. The other two hubs are the Kodiak Area Native Association and then the Southeast Alaska Tribal Ocean Research group. And so I don't always know who the sampler is in this group. I usually kind of try to take a broad approach and to just always assume that these are tribal and sovereign data, and I don't present their data. So I do partner with all of these groups to merge the nearshore data and monitoring and signals with the offshore monitoring that I'm doing. And sometimes I have permission to not only see the data, but to map it out with our results or to present on it. Usually I only present if either the regional association can join me or if that community's a monitoring person or office can join me. So I can speak a little bit more towards the community data and the discussion afterwards, but I'm not going to present those data. I will say that I hope I'm convincing some of the communities that the winter data is really interesting and it's a lot of the data that's very hard for us to get offshore. So anyone that can get data in the winter is going to be really exciting for us. So we can talk about this a little bit more in a group discussion. And then just some future work. It really, for me specifically, for my federally funded projects, it's to maintain those long-term monitoring sites. We're also planning future surveys. And so we want to hear your opinions on where and how you'd like more information. It's to share and to listen, really. And then for this region, I have a couple of photos here. We're working with some of the crab industry researchers in the Southern Bering Sea. That's Jared Weems at ADF&G and Mike Litzo with NOAA. We're interested in talking more with folks that are eating and living and working with crabs and in the Northern Bering Sea and in Norton Sound specifically. So if you want to talk more about that, let us know. You just heard from Dr. Kay McMonagle at the Strait Science Seminar just a couple weeks ago on the community partner cruise this past summer on the Sequoiac. The community members on that cruise collected carbonate chemistry samples. And we just finished analyzing those here in the lab a couple weeks ago, and I reviewed those data with Kay yesterday. So they're hot off the press. I think that group is going to report back first. So again, I don't share other people's data unless they've had a chance to do their messaging first and their interpretation, and then give like very clear approval later. But Kay or I can talk to you more about that later if you want. And then there's a University of Southeast group that has several big projects. One is to synthesize all the tribal data in the Southeast region into a regional model. I think this could or should be done for other regions, including yours, in the future. I'm really excited to see the results of some of this work. They're hoping to identify local risks from climate change, which species, which place, which time of year, and what's driving that change. Their ecosystem is a lot different than yours. You know, you have the biggest effects from those changes in the cold pool, like Gay is always telling us, changes in sea ice conditions. It's a lot different from what they're thinking about down in Southeast. They're really looking at how the observations for ocean acidification help predict other risks, especially harmful algal blooms. So this is where I think your group might be really interested to see what they come up with. So I'll be sharing those with you and through Gay's office in the future. And there's also a new resiliency project that was just announced and funded. You might see some news about that. This again is for Southeast. That's working with some of the social scientists, learning how people are adapting to ocean acidification. So we can share that with your group whenever you want. And the ultimate goal here is always actionable information. This can often take many different steps and back and forths and different paths from my direct observations, some of the values, and some of the maps that then gets into the decision making. I'm not a decision maker. You all are the decision makers. And so, however, we can provide more information to you, please let us know. For your region, I think the most frequently updated resource that we have is probably the Bering Sea Ecosystem Status Report. There is an ocean acidification index in there that you can read every year. It's mostly forecasts and hindcasts from our model outputs, and that's validated by all of the observations that I shared with you today. So it's all the same information, just kind of formatted in a different way. Um, and then the other kind of highlight I wanted to announce is that we have a new ocean education program. It's called 4-HPH. Chemistry to me is really exciting. I think the most fun part about this project, this was youth ages 5 to 12, is we did a lot of chemistry in the ocean. They led their own monitoring program from January to May of this year. And we also did a lot of chemistry in the kitchen. And so that is a great place to kind of start introducing some of this information. This is led through the University's Cooperative Extension. Jasmine Shaw is the lead of the program in Sitka. And then the educator on this project, Christy Buffington, is here in Fairbanks. They developed the curriculum. So after Jasmine led this with her after school group, all last year, then they rolled it out into the 4-H summer camps, and it was a really great program. We got a lot of really great feedback from the families in Petersburg and Angoon, where this was held. So if you're curious to learn more about ocean education, or if you know if any youth in your area are involved in 4-H or interested in that, we can bring this program to your region. But all the curriculum and lesson plans will be public. So 4-H schools, any other kind of education or after school programs can use all of this. It's all available to you. Just let me know if you want it. So that's the end. I got my main take homes again, which I already told you. So I think we're done. Here's the QR code for my website if you want to look at some more resources that we have. And I have my email address here, but I'm available to answer any questions and talk about anything that I brought up today.
All right. Well, thank you so much, Natalie. You had my head spinning. So before we go to questions, what we do is the Straight Science audience we're grateful you took the time out of your day late at night here to give us an opportunity to learn more about this topic. So give Natalie some love in the chat. It's never easy to be a public speaker, and so uh, there you go. Or look at that. People are so hip these days. They know how to do all that
Thank
animating.
you.
So anyway, so with that, I see we have a question. Doug, why don't you go first? Doug Molyneux. He's been very patient. He also had a little question in the chat as well, and I don't know if that's gonna come circle back. So go ahead, Doug.
Hi.
You got the floor.
Yeah, very informative, Natalie. Thank you very much. I have a question. I'm afraid it's a biology question, but your first few slides, you were showing the species and their level of sensitivity. But I'm kind of wondering, is that direct effects versus indirect effects? And with the indirect, what I mean is, even though the pH may not have it be killing an organism, it may be reducing the amount of food that's available for them if they're dependent on juvenile crabs or what pteropods or something like that. So, can you comment on that?
Yes, thank you for that question. So the response that I'm summarizing here is direct. So this is the organism that is living in the tank, and they're manipulating the chemistry. So
Yeah, okay.
that's what's changing. So they know that if there's any physiological change to that, it's directly related to what they changed in their environment. There's other work being done to link the food web, like you mentioned. That's probably going to be the most important factor, right? Is the linkages between all of that. But it's so hard to study just the direct effects, that I think they need to kind of start there first to see what the change is on each different species, and then start to think about how all of that is kind of moves throughout that web and the different trophic levels, like you said, like the predator prey relationships.
Okay, thanks.
All right. Thank you very much. Charlie, go ahead.
Yeah, I'm it seems counterintuitive to me that in the winter the CO2 goes up. And here in Norton Sound and further north, the ice covers the water and it also serves to reduce mixing from wave action or wind action.
Mhm.
And so I I wondered if you had a comment about that. I would have thought that also there's algae that grows in the ice, and so when ice breaks up in the spring, all that algae is out there gobbling up carbon dioxide, I think. So it just seemed odd to me. So
Yeah, thank you. Thank you for that. So I'm kind of looking at this as at two different parts, and you tell me if I'm right in thinking. So the first part of that was, the higher CO2 in the winter. So the way that I think about it, like I showed all those lines from the M2 mooring in the Bering Sea. And so they're mostly lower, they're kind of going down during that growing season from like April to, August or something. And then those years that we had the late data where we did have winter observations, they were much higher. And our thinking there is that CO2 is coming to the surface through storms and mixing, but it's actually accumulating deep within the water column. And so the Bering Sea shelf is so productive. You have so much stuff growing, growing, growing. The first kind of signal is those phytoplankton, those ocean plants gobbling up all the CO2, and then everything that comes after that, the zooplankton and everything else. But at the end of the growing season, that's all dying, and then that carbon dioxide that the plants took up is then turned into organic whatever, based on like if it's poop or if it's a dead zooplankton or whatever it is, but then that's all raining down through the water column, accumulating in the deeper waters. And that's where the decomposition starts to begin. So once decomposition starts to begin, that organic carbon is all re-released as carbon dioxide. And so you might have carbon dioxide building in the bottom waters throughout the season when that like death, I like to think of it as like the death season, right? And then once you get that first big winter storm that comes in and overturns the whole water column, you bring up those low values from the bottom, and then they escape out the top. If that lid isn't on it, that sea ice lid, so it's able to exchange in between the two. So then the second point that you bring up with the sea ice and everything else, these are excellent questions. I have the same questions. Maybe we can think about them together. It's really hard for us to get those values. There's been a few times I go on the spring mooring cruise in the Bering Sea every year. I have for years and years. And there's been a few times that we've gotten out there that we've been close enough to the ice edge that the algae is still like alive, because a lot of the times it's broken enough that it's kind of past that growing season. So we just don't have a lot of good information about those values. And we don't have those direct observations, but that's right at the surface. And so I might be misrepresenting those, high CO2 values when I talk about that at the buoy, because it's venting at the surface. That's how it gets out of the ocean back into the air, but it's accumulating at depth. Does that make sense, or does that kind of address anything?
Yeah, that especially in the fall period, I think I I see that. But I so the area around Norton Sound and the Bering Strait's quite shallow, and you can see it because your 75-meter depth graph didn't have any data there because it's not 75 meters deep.
Yep.
The but I've done sampling on ice algae, and boy, there's a lot of it.
Yeah.
And it's really prolific starting in March until ice out, or even beyond ice out. And so I I th- I think you need to sample or find samples for that spring period and see what that's doing. I think the ice covered portion of the oceans out here might be totally reversed from what you think.
Yeah, I completely agree with you. And Gay and I were even, I think, kind of strategizing before this started on
Mm.
how we can get some of those measurements. We don't have any measurements from the March season. So yeah.
Yeah.
We definitely would love to get more information then.
Yeah, Charlie, I was saying that, and I think, you Natalie, you've been talking about the Bering Sea as if it's one. We really look at
Right.
it as two different
Yes.
ecosystems here. So we're like Northern Bering Sea versus Southern Bering Sea. So I know that a
Right.
lot of the research, like that you mentioned, that Tom Hertz and his Newport, Oregon tanks, where they
Mhm.
put creatures in, like you were just saying, and then they crank up temperature or make it
Yeah.
whatever they do stuff, and then they're right there with this controlled tub of
Mhm.
water, and they can watch how the fish or the crab or whatever it is. um but we'd love, I think, if people, I see Opik, I got your next. The the researchers, of which we have many here in the region, and our fishermen and our CDQ group, and I mean, we've got Fish and Game, and we've got citizenry that is very skilled and knowledgeable. So I appreciate you mentioning that, and I hope that you're able to maybe work with the entities we have here, as opposed to bringing people from the south up to the north. Like
Oh, yes.
yeah,
Yes,
yeah.
yes, absolutely.
So, Opik, I saw your hand up. Go ahead.
Uh, Nice presentation. Thank you very much. I was thinking to the year 2021 when we in Diomede were pulling up our blue king crab over the ice by hand line,
Hmm.
and then there were several of us pulling up the crab, and we were all on the south side of the island, and um, the crab that we were pulling up, they had their crab shells weren't fully, they didn't calify fully, so they had abnormal looking legs,
Yep.
and so I thought, gee, I wish I knew what the temperatures were, that summer, what it was, or even that winter, what was the temperatures there, in the winter, what was the ice condition then, also in 2020. The blue king crab, they're offshore in the summer and fall season, they're offshore, right? And then comes winter and spring, they come inshore.
Mm-hmm.
So we're pulling up these crab, and I'm thinking, because the ocean was acidic then, and I don't remember if we did OA sampling then, but I know that the ocean was acidic because these crabs, the crabs, even the big crab, their legs were very thin, and I did take a bunch of pictures and took note of it. I'd have crabbers come and show me this is not, normal. So
Mm-hmm.
we were concerned as to whether they should eat the crab. So that was one concern from the community. But I do recall that these crabs they didn't grow, to their full crab shells. And, I also think about with carbon dioxide and how it releases more from the water in the summer season. Of course that will, because there's nothing covering it, but then you also think it is also being released in the winter as well. If there's holes, the ice doesn't freeze fully anymore. We all know that here in the Arctic you're gonna have open waters here and there. If you look at Diomede, both north and south side remain open. We've never seen full coverage from the ice freezing on the north side of us fully. There's always open water for many years now, and then south side as well. So, and we also know, everybody knows here on this Zoom, that this ice is not thick. It's not the thick old multi-year ice that it used to be, because I remember when I use my toolbuck and I drop my toolbuck down and I could dig a hole maybe 5 feet, 5.5 feet, that ice would be. Why I know? I went inside it before I punched all the way to the bottom of the hole. I went in it and I said, "Hey Gabe, just wave." He was looking for me. He couldn't see me, and I climbed back out of that hole. I took one punch from my toolbuck. Here comes the water. And I remember before I punched that bottom layer, to poke through that 5.5 feet ice, it was very dark right there, very dark, dark bottom sheet. Whereas now, if I'm gonna tool, it's gonna be maybe 2 feet, maybe 2.5 feet. The ice on the bottom layer never dark, not like what we saw in the past.
Mm.
So that is something to think of too. The thickness of the ice and how it carried the CO2, and how there was less back then, less algae growing under the ice. Of course, algae is always under the ice, but then we're seeing it more so now because the thickness of our ice is not thick anymore.
Mm-hmm. Mm-hmm.
That's just what I wanted to add.
Well, thank you, Opik. There is a comment from Doug Molyneux. He just had a quick question when you were talking about the funny looking crab, the odd ones. Were they new shell blue king crab recently molted? That's the question.
Yep, and then usually, and around that time, they're gonna molt, right? And Diomede scene, we pulled few crab, not very many, but over in the earlier years before climate change, really everybody started to take notice of it, and warmer water conditions. Well, we've had crab that just molted, and we pull them up, but then when we pull up them crab, there were no odd shape, crooked legs, like that. Meaning these ones were, of course, we knew then that the ocean was acidic because they didn't have the correct me. You have to correct me. The aragonite, right? Is that what it is?
Yeah, aragonite. Yep.
Yeah, aragonite or aragonite. Well, they need that to calify, right? The crab shells.
I think the crab shells are a little bit different than like a clam shell. I think when I'm thinking of the aragonite, speaking more towards the clam
Oh,
shells.
yeah. Like,
But the crab are definitely affected by changing chemistry. So, that term I'm using all of those different variables kind of lumped in together there. So yeah, I really appreciate you sharing that with me. I'm gonna reach back out to my partners and answer your questions there. So I'm gonna get you the 2021 temperature uh
awesome.
data for you. And then I think you also said you wanted 2020. So I'll reach back out to Gay to be able to get you once I find out who has that information for us to share that with you.
Oh, that would be super awesome. Oh yeah, and I did have another question. Oh yeah,
Go for it.
when you're collecting your samples, your OA samples, how many meters down are you collecting if you are doing it over the ice or have you over the ice?
Anything would be great with the ice because we don't have any data. And so I think that that's something that we're really working towards with this community monitoring project. So there's been a lot of turnover. There's been a lot of changes in capacities like across the board. So that's
Yeah,
been the hubs that are doing the analysis, and that's also the communities that are doing the monitoring. And so they've made a lot of really excellent progress with a lot of new personnel to get these new formatted reports out to each community to give them the same exact information so they're all comparable, like nobody's getting different information. It's all presented in the same way, and it's all presented with exactly the same variables that I presented today. And that's a big reason why I chose to go through all of those, which might have been a little much, but all of that information is going to start to come out in these community reports. And so as the communities start to think about what that information means to you all, then you can also share it with your neighbors, and then you'll all be talking about the same numbers, the same variables with the same respects. And
mhm.
so I've been given permission to see some of these reports. I haven't seen all of them yet. Not all of them are done yet. I have a feeling that there are going to be a few that trickle in that have winter ice covered data. I did see the GNOME data this morning, and there were no samples collected through the ice. And so if your community in Diomede has some of that, that's I think the next report that I'm probably going to request. So that
Okay.
that office will reach out to you all first to give permission to me to see it so we can share and combine our offshore and nearshore data. And then we can all have a conversation once they give that to you to talk about what this all means and kind of start thinking about future planning and how we want to maybe change when or where we sample.
Yeah,
Whatever you all want. We want to hear what you're not our just wants, but yours. It's your data. So
I would like you to come to Diomede and collect OA samples with me.
oh yes, please. Okay, we can definitely visit. So
Yeah,
yeah,
this winter, let's crab
yes.
and
Yeah.
get some samples.
Okay,
Thank
great.
you very much. I really enjoy your presentation.
Thank you so much. Thank you.
Yep.
And thank you for helping collect all these data.
Yeah, we'll continue to do it. Yep.
All right. Thank you, Opic. And thank you, Natalie. Charlie, I see your hand up again.
Yeah,
Go for it.
I can't keep my mouth shut.
That's
So
good. That's why we're here.
they when you're sampling through the ice, it's important to get your sensors down below the ice because there's when you're near shore here in Nome, there's fresh water floating on the salt water, and it greatly affects the, the salinity and pH and everything in the hole. So if it's the hole that you dug for your crab pot is
Yeah.
fills with relatively fresh water compared to just a couple inches below the ice. And likewise in the springtime, when the ice might melt a little bit,
Mhm.
you get this fresh layer just under the ice or in the ice. And it's really important to get your sample below the level of the ice. That I think that would apply in Diomede or anywhere.
Yeah,
So
I
anyway,
like that.
Below the lens, huh,
yeah,
of fresh water.
right, right.
Yeah.
Um, yeah, Natalie, what do you think about collecting OA samples from different levels? I mean, different, yeah, like from
Depth.
closer to the bottom of the ocean,
Yeah, that would be
bottom.
That would be great. And we have different sampling tools that we can send you that can
Okay.
send different bottles on a
Yes.
line through your hole.
Okay.
So we can definitely I'll be contacting Eluctic Pride first and see where they're at on getting your report ready for those data. And then they'll contact you first, and then we can kind of get into this and this planning and strategizing. Yeah, definitely.
We already contacted them, and they have already shipped me a kit for
Oh,
collecting OA samples. So we're there. So when you and I work on talk together over the phone, sometimes next week, um, we can discuss. We can discuss collecting samples from the from the bottom of the ocean and maybe closer, maybe to the mid. Because,
that
like Charlie says, it is the water at the top is the salinity does change. It's fresh water and salt water, so it could read instead of reading at 32, it might read at 35.
Yeah, right. Okay, thank you so much.
Yep.
Yeah, can't wait.
Thank you. Me too.
Yeah. So, and thanks, Opik, for that. That was good because the Bering Strait is usually people will say, oh, it's really well mixed, right? Because you have such this massive current. But there
Mhm.
are times when the salinity is so different, you can have a harvested seal laying it's supposed to be falling to the bottom. Somebody
Oh,
didn't get to it in time, and it'll be just suspended 5 feet down, and that's just the difference in salinity. So it's
oh, right.
it's not a insignificant topic. And then you have near shore, not near Diomede, but near Nome, you have Snake River, Cynic
Mm,
River. You've got all this runoff, Nome River,
right.
all going on all over Norton Sound, Yukon River, under the
Mhm.
ice. So you want to make sure you got that one nailed. So I agree with what Opik and Charlie were saying. You really want to know where you are, when you're getting that, because it might make a big difference.
Yeah, thank you.
Doug, go ahead.
Yeah, excellent. Just it's really fun to hear these connections being made here. This is good science happening here. My other question might be a little out there, but in deep time, geologic time, there
Hmm.
have been significant die-offs that are at least partially attributed to acidification events in the ocean.
Hmm.
Do you have any idea how far off we are from those scales?
I don't have those off at the top of my head. There has been a few new reports in the last year or two, I think, that have come out that are really starting to link that geologic record to our modern times now a little bit closer. But I think the thing that I think of also is just the co-stressors too here. And so not only thinking like this changing in carbon is what's going to kill off everything, but really all the other things that are going along with it. And so that's the changes in temperature, that's the changes in sea ice. And so I think that
Oxygen.
yeah, and deoxygenation in the North Pacific is a huge thing. And so I tend not to think just about those like extreme carbonate die-offs in the ocean, which definitely exists, and there's a lot of great paleo work being done to look at those records, and that will helpfully help and inform us about what's happening now. And I think a lot about those food, right? Like all those different plankton, all of those shelled creatures that all of our favorite bigger species, our fish and our seals and our ducks and everything else that are feeding off of those. That's where we kind of get into that trophic. And so I
And
kind of
us.
yeah, and
And us.
us, right. Yeah. So I kind of stay away from just that one kind of thought. But the next time I see a report come out that links that with some new information, I'll forward it to Gay, and she can share that with you.
Okay, I was just interested in the general context, how. Anyway, okay, thanks.
I think we'll have to get you back, Natalie, next year. It sounds like there's going to be a lot of information exchange, so we would be interested in that.
Oh yeah,
Um,
definitely.
I have I don't know if it's a question. I guess it is a question, but I'll start off with, the Newport, Oregon
Mhm.
NOAA fishery guys that are doing these experiments in these separated tanks. I know I've
Mhm.
happened to be there one time on a
Oh,
surprised myself, actually ended up going in there and getting a tour. But the people, it would be good to have a picture maybe so people could see these big tanks and then they can make the crab and fish live in different environments and see how they do. But in there, do they do any other bivalve besides oyster? Great for the Gulf of Alaska, but really, could we get them to do an Arctic surf clam? Do you have, could we get them to do something like a Serapes or the, number one walrus food, that sort of thing in the Bering Strait region? Some good
yes.
clams, not just oysters, which have a pretty
Yeah.
robust shell, but I just didn't know
Yes.
if that was some, that's not a question. That was
No,
just,
that
I was like,
that's that's
oysters.
wonderful. So this is something that the network, so I'm on the executive committee for the network and we report back to all the funding agencies. And this is something that we tell the funding agency every year. They're like, what do people in your group want? And we're like, not the commercial species. That nobody is asking for that. And we give them these lists. So I appreciate the additional lists. We will report those names of those species this year. So to be specific, the Newport lab is working on groundfish. So they have a special thing. You saw it. I've never been there, but
It's
their
impressive.
their
Big,
their
huge.
special machine is to super cool the water and so that they can have minus
Yep.
1.8 degrees centigrade water to grow those Arctic, not grow, but
They mimic the coal pool
keep those Arctic
in
cod
some of the,
alive, right? So
yeah.
so my understanding is there's no other facility that's able to do that. The crab work is being done in Kodiak, and then most of the shelled organism work in Alaska. I mean, it's being done everywhere, but the ones that are doing that in Alaska is happening at Aluktik Pride. Um, my understanding is that St. Paul is also bringing on all of their new lab. And I don't know what they're going to be growing in their tanks. But maybe this is something we can talk to them about too.
Yep. That would be great. And
Hmm.
Doug, you're a bird fella, aren't you? You're a bird expert, seabird expert. If you had to pick
Actually, fish.
fish, shucksaroo. Sorry about that. Good on you for fish. I was going to ask if anybody had like the number one clam that eiders, we've got walrus, bearded seal. They kind of groove on the same sorts of clams and things. But then you've got little itty bitty like nuculana, nucula, those tiny little clams that eiders are pounding down off St. Lawrence Island and probably in eastern Norton Sound in those areas where they've been known to visit. So I just wanted to, never mind.
Opik, did that ever come up when you all were trawling all the creatures off the seafloor and pulling the different clams and identifying everything? Did they ever bring those clams up?
Yeah, so it depends. Like if we were off of Gamble, we were pulling up different clams. Um, and I know they did take some for sampling, so I can't give you any answers about that. But yeah, they did pull up clams, and I want to tell you, there are clams also. If somebody wanted to study them, I don't think they are doing any studies on clams near wells.
Mm.
Because wells they get the
Hmm.
what are the crow eye or shell or whatever,
Well,
Neptune,
we just
and
got samples
those.
from whales. They just had a wash up of Serapes, actually, and Arctic surf clams,
I was thinking,
Macromeris and Serapes.
were the Serapes, were these the yellow ones or the tan ones?
They're kind of tan. They're kind of pointy, a little bit round like this, and they have almost a distinctive
Oh
ridges.
yeah, okay, I remember.
Yeah.
Wow, I
And
never
then
knew they
the
had
surf
Serapes.
clam looks like a kind of like a cartoon of a clam. It just looks like a big old clam. Um, and there's
Oh,
there's others where there's Tilionids. There's lots of different clams
butter
in Bering
clams.
Strait.
Yeah.
Yeah, yeah, all of that, Macomas and all of that.
Oh yeah.
So, but this
So,
Opic and Natalie, you make me think for the crab
Hmm.
that Kodiak, I guess, is looking at. That's my mistake. I thought it was, but for the crab, you said blue king crab not affected. Is this and that snow crab not affected, red king crab affected, We also
Mm-hmm.
have the Hanasaki, but I don't know. That's who that falls under. But the is that all lab experiments? And
Yeah.
that would be the first one. Is that lab experiments? And what is it that the king crab, red king crab, is going on with him that he's not doing very well, but the blue king crab and the snow crab can do? That's my first question. And then the the second is, what do we look for? Or are we that far along? Maybe that was kind of what Doug asking about the change. Where are we? Um, what do we look for? Is it so, are we at a point where we could see like OPIC saw these, or OPIC and the residents of Diomede saw something odd going on? Would we be seeing that? So how do why do red king crab get the loser card and they
Yeah.
suffer? And then um, what should we look for in this region? Because everyone's handling seafoods.
Yeah.
Habitat.
So I think for the specific species response, I really don't know. A lot of
Okay.
this information is just a summary of what is on the website. So I sent that link here. So based on my consistent questions that I'm always asking the fisheries biologists with the blue king crab, I feel like they have said something to me before where there's some sort of evolutionary adaptation. I don't know why a blue crab would have that and a red king crab. We still haven't talked about gold king crabs or brown king crabs or any of these other things. For me, with my very, very limited biological experience, the take home message for me is just that it's very species specific. So we can't lump all of these organisms in together. I'm just saying like crab are affected. So I think that
Yeah.
there is a different adaptation in blue king crab, and we can read through these reports on this website to kind of drill down into that, or we can ask the experts to report back to us. The understanding for me with the snow crab and the red king crab is the new results that came out this year is really linking many years of the recruitment data that all of those fishery scientists have been working on for decades and overlapping that with our hindcast model. And so I do the observations. I've been monitoring all these places for the last, I don't know, I think it's like 15 or 16 years. And then we give all that information to the modelers who provide the bigger spatial extent. So they're able to model the northern Bering Sea where we have very few observations. Just like you said, it's very different than the southern Bering Sea. And then they're able to link all that fishery and recruitment data on top of each other. And that's where the statistics, all this like overlapping information has kind of come to pass. And so there is something special about what has happened in the recruitment of red king crab. I think the other thing that we're really like arm waving about here is that we don't have a lot of nearshore data and we don't have hardly any data along the Aleutians. So if we're specifically talking about that southern Bering Sea picture, we're not measuring the values of where maybe the juveniles are or the larval stages are. That's going to be quite different than when we're talking about the blue crab, king crab fishery at Diomede. Um,
Or
so,
St. Matthew Island
or
or
St.
St. Lawrence
Matthew.
Island
Yeah,
or
very,
Yeah.
very different. And so the other thing that I want to say that I do feel comfortable talking about, is a big reason on why I choose to show those like big averaged maps, and not just kind of just only always present like my own specific data from each project, is to really remind people that the water chemistry changes naturally with depth and with temperature.
Hmm.
And so a lot of the things that I hoped I like even began to explain here is that this is a lot of natural processes that are going on. So I would think that a lot of these organisms are already living in these conditions that we might say are like unfavorable, and they have some sort of adaptation or mechanism to adapt to that or to be resilient in spite of it. So maybe they've filled that niche by saying, like, I can survive at this condition, like the blue king crab. I can survive at these, low pH conditions because I've filled that niche. But then it's all this other co-stressors that's happening in tandem with the changing chemistry, like the changing cold pool and the prey and the temperatures and everything else that's really affecting them. So I think
Predators.
there's a lot
Well,
of other physiological responses that could give you those changes in like visual appearances of shells. That's not just chemistry.
yeah.
So all of this is happening at the same time.
And when you think about it, so if you wanted to differentiate red king crab and blue king crab, which are king crab species, think about red king crab as a mucky bottom crab, you know, blue king crab is a rocky bottom habitat. Up here in our where we have our blue king crab, our water is always a bit colder than Norton Sound water. Will be warmer. Think about that.
Yeah, it's a good one.
Hmm.
So I guess the take home on the answer is if you see something odd with the crabs, it doesn't necessarily mean that it's ocean acidification related. I would say I would recommend that tribes or we don't have co-management, but we certainly have State of Alaska, Alaska Department of Fish and Game. We have other um, entities that would welcome those that are no regional, they have regional contacts. Um, and NSCDC has always got tribal or community representation, and they can get word to people back to Fish and Game, back to Norton Sound Economic Development Corporation, which is our CDQ group here. So I would recommend if people see something funny, take a picture and make sure you get it back to the local entities here in the hub, and they'll be working from here with others. So just if you see something.
Thank
And
you.
Doug has been very patient. Go ahead, Doug.
Trying to remember my question here.
I
I think
sorry
you
about
you
that.
you kind of touched on it, but when Gay mentioned about the lab experiments that were done,
Mhm.
um, life history matters, or the life stage.
Right.
And so I'm guessing a lot of that lab work they did, they were probably using juvenile or immature crab just for space.
Yeah.
Mhm.
Um, and it could be very different effects on the larval stage, the zoea stage for crab, as opposed to the adults.
So if you go to that website that I put here in the chat, it has a annotated bibliography. So it tells you what each paper that they give you says and it summarizes it. And in that, you'll see a long list over more than a decade of all of the papers that have come out of that crab lab. And their story does change depending on the timeline when you begin to look at those reports. So that's another like caution, right? So exactly what you just said. If their first experiment was on this larval stage and they did it for 3 weeks and then they wrote a paper, that's a lot different than if they did multiple life stages over a longer period of time.
Yes.
And then
Yeah.
now they even have the information that's intergenerational. And so
Yeah.
they've moved through all of those life stages that you've mentioned, and then even moved on to the follow on generations. And that's why no one has ever publicly made a link between any major changes in a specific recruitment or fishery, because no study has that level of information until now. And so in the early years, it was just like, we don't have any information. We'll take what we can get. And now these studies have happened long enough and have repeated enough that they're able to tell a much bigger story, but it's still not in the ocean, right? It's still
Yeah.
in the lab. So, um, so
Good point.
yeah, no, I think we'll continue to evolve and change that story. And that's where I'm just very, very grateful to work with the network. Earlier in my career, I didn't have that kind of really group, kind of statewide, multidisciplinary, multiple knowledge systems. We didn't have that kind of experience in the previous work that I did. And now that I have this, we've been growing for more than a decade now. it really facilitates this like very holistic discussion that you all have led here. So I really appreciate you allowing me to listen to a lot of your ideas and comments. I think the network is a great way, and if you're still interested, I would really invite you to join us, or at least sign up for the newsletter, because I think that's where you'll continue to get a lot of really great information on a lot of the points that you all have brought up.
I just
And
want
we will,
to chime in
go
too.
ahead, Doug.
Your presentation was excellent, and this Q&A section has been just outstanding. I really enjoyed it. Excellent, excellent.
Oh,
Thank you.
thank you so much.
All righty. Well, we're coming up on 8 o'clock, so we better let everybody go home. But are there any other questions, comments, thoughts?
Thank you very much, Gay Sheffield and Natalie. This was awesome. Looking forward to meeting up with you, Natalie.
Okay, thank you, Opik.
Take
All right.
care and happy December.
Yeah, you too.
Thanks. Thanks, Opik. Appreciate that. Next week's Straight Science, we've got 2 more weeks of Straight Science, and then we've got Christmas, believe it or not. And then we're going to start up again. And once we start up again in January, we've got a full lineup going right on into the spring. So the next 2 Straight Sciences are going to be walrus heavy. So I'm excited about that. And the next one will be on Thursday, December 11th, 6:30 regular time. And it's going to be an update by the Fish and Wildlife by the U.S. Geological Survey, Bill Beatty, and Irina Trukhanova with the U.S. Fish and Wildlife Service Marine Mammals Management on the Norseman cruise, which had on board with it our very own Madeline Kowalik of Nome. And they're going to talk about their population estimate and the work they had done and the results of that in 2025, the spring cruise, and then also what the plans are for 2026. So they have talked to us the year before about the cruise, and they're going to do it again and give us what happened and what they saw. So there was a lot of other things going on with harmful algal bloom sampling and others. So we'll hear all about it next week, next Thursday, and I'll start sending those notices out. With that,
Gay, I just want to
Yeah.
mention, on those walrus talks, just as a primer, I think it was on PBS on Nature, they had a special or an episode on walruses, not just Round Island, but they actually talked about things going on in Norton Sound. So that'd be a good
Wonderful.
one to watch before the presentations. Thanks.
Yeah, wonderful. Well, we're surrounded up here. That's good for everyone, and we're surrounded by some of the best walrus experts on this side of the hemisphere.
Oh, for sure.
So, I appreciate that, and for everyone, we'll see you on December. I'm a walrus. I'm really interested in what they're going to have to say, and as well as the next one after that. And we've got another walrus one, but that'll be later in New Year 26. Which we're almost at.
Yeah.
So everybody have a good night and take care. Natalie, if you want to stay on for 1 second more while everyone says good night, that'd be great if you're up for it.
Okay, yeah, thanks.
All right. Have a good night, everyone. Take care.